Hello, everyone. Since we are living in a fast-moving, modern, technological world, the mobile devices has played one of the most significant roles in our lives. So Apple and Android are two of the most dominating mobile platforms in the current world. So having said that, let me ask you a bit of an interesting question with the start of this presentation. So Apple and Android, which device would you think that has a better performance in a Wi-Fi environment? So this project is all about that. So my name is Danushka. So this project is all about doing a comparative analysis between two of the main devices, which is Apple and Android, based on their performance uh, in a Wi-Fi networking environment. So this Wi-Fi networking environment has been configured using a programmable device called Raspberry Pi. And the other specialty of this Wi-Fi network is that it has configured as two SSID frequencies. So let me walk you through to the outline of this project. First of all, I'll be defining the problem statement and as well as how I designed this project and as well as the implementation steps and procedures that I followed in this project and also the results that I managed to gain out of this project and ultimately the conclusions and the future directions of my project. So first of all, let's identify the problem statement. Now, Apple and Android are two of the most competitive devices in the current world. And on the other hand, we are moving towards 5G and beyond 5G. So we are experiencing a higher data rate with the enhancement of the telecommunication services. Uh, Therefore, in customers' point of view, uh, the customer is always keen to experience the higher data rate and the higher networking throughput in their devices. So here, there's a bit of a confusion or controversial arguments between two of the devices saying that is Apple or Android device has the better networking performance under a predefined Wi-Fi scenario. So this confusion made me to do this project analysis. And also it's a better way of identifying the best performance device under various networking scenarios. So this is the big picture of this project. So this whole project has been conducted by using this main device. So this is called a Raspberry Pi, as you can see in the big picture. So this has been configured in such a way that this acts as a wireless access point. In other words, wireless router. And the other speciality of this wireless access point is that we'll be configuring this as two operating SSID frequency. One is 2.4 gigahertz and the other one is the 5 gigahertz. And also the other speciality is that these two SSID frequency is running simultaneously. As you can see in this design, the Android and Apple mobile devices are connected wirelessly. So this is the basic setup of this project design. And let me walk you through the implementation procedure. So first things first, first thing is configuring the wireless access point with two SSIDs as I explained just now. And the other one would be the RSSI value measurement. Now, I told you that for this Raspberry Pi wireless access point, the mobile devices will be connected wirelessly. So now we have to do a measurement of the RSSI values, which means the signal receiving strength values. So to measure these values, we'll be doing certain benchmark tests in such a way. For example, these connected devices will be varying their distances in such a way that their RSSI values will be varied and fluctuated. and their throughput levels will be varied and fluctuated. And another important aspect of this implementation process is uh, configuring the algorithm to analyze the network parameters. So this network parameters, how I'm going to analyze this performance. One would be varying the distances with the RSSI value, and the other parameter would be determining the network throughput with varying the various decibel values or the RSSI values. So likewise, I'm going to do the implementation process of this project. So now, as I told you, the main important initial step of the project is configuring this Raspberry Pi in such a way that this accesses two SSID frequency. One is 2.4 and 5 gigahertz. So this shows and this proves that I have successfully configured the two SSIDs successfully. As you can see, it is shown in green color. It's shown as perfectly running fine, and it's active as well. So as you can see, the WLAN 0 and WLAN 1 has been shown there. So WLAN 0 is the 2.4 gigahertz SSID, and the WLAN 1 is the 5 gigahertz SSID. So this is the most important thing of my project. Writing the script in such a way that doing the outputs of this project, one important output and in consideration would be RSSI value versus the time. I'll be connecting the devices to this Raspberry Pi and varying the distance. So I'll be measuring the RSSI values with the time and how these RSSI values were fluctuated with the time for the two of the devices. And the other one would be RSSI value with the data rate. How these devices has changed their RSSI values, has changed their data rates when they change their RSSI values. So in order to output these results, this is the main algorithm that I write inside this Raspberry Pi. So this is the main important results that I managed to do output. As you can see in the screenshot, if you look into the third line, you will see even the time has gone, but the RSSI value has shown as 53, but for Apple, but for Android, it's showing as minus 63, which means in the same time stamp, the two different RSSI values means Android has fairly shown a weaker RSSI value. So Apple, in this case, Apple has an upper hand by showing a higher RSSI value. That's an important point of this project. And this one is more like the same thing which I did for the 2.4 gigahertz. Earlier one was the 5 gigahertz. In this also, it's showing as even if the same timestamp, Apple has the upper hand of RSSI value and the Android has a lower RSSI values. As you can see, the first timestamp it shows as minus 76, but in Android it shows as minus 86. So this is more likely the other band, like earlier it was 2.4 and 5 gigahertz. Now this one is basically on the data rates. The earlier testing scenario was RSSI versus time, and now this one is the RSSI versus the received data rate, which means the received throughput. Now, if you closely look into the third line of this graph of this table, we can see the same RSSI values, which is minus 56 and minus 56, but two different bit rates. Now, which bit rate has the higher bit rate? Now, it's obvious that Apple has 65 bit rate and Android has 39 megabits per second. So this shows, even though the same decibel values, two different bit rates are shown, which means it clearly illustrates that two devices has two different performances. The same thing I have just told you, I have put it into a graph so that we can easily visualize the two different performances. As you can see, the blue line is Apple and the red line is Android. So here you can see the fluctuation of the RSSI values, and Apple has the upper hand of adjusting in advance to the Android one. Android has a bit of a latency to adjust to the RSSI values. So this is basically the graphical representation of the data that I have collected from the program. And finally, we'll be coming to conclusion. As you can manage to visualize, Apple and Android, those devices have shown their unique performances, but Apple device had the upper hand, and it has shown a significant level of higher performance when it comes to RSSI value capturing with the time. And also in the other scenario, Apple device had the upper hand when it comes to comparison of the throughput levels. So that is our main conclusion based on the results. And let's figure it out, the future direction of my project. So I'm very keen to figure it out. What are the reasons for the performance difference of these two devices? Obviously, there would be certain hardware parameters, but I should mention that for this test, I chose almost similar level of equal level of grades of Apple and Android devices. And the other future work aspect would be the testing in complex network environment. So this one is a basic networking environment with two SSIDs. I would more like to keen to be more complex, to build more complex network environment in such a way that this testing scenarios will be more sophisticated. And also, I would like to build an IoT Wi-Fi environment in such a way that to determine how these devices will react according to that. So that is basically that. I hope you had an interesting session. Thank you so much. Thank you.